Hi, welcome to Quality in the Automotive Industry, the channel where we show you everything you need to know about the quality core tools. This video is part of the series An Easy Approach to MSA, the Measurement System Analysis, and the subject today is the Gr&R. When we talk about quality, we think immediately about the requirements and know that if they are fulfilled, the quality should be okay. However, in production, process parameters and intermediate products must be measured to guarantee that everything works well. And if we find problems, we can immediately react and solve them. The heart of quality is the measurement system. Gr&R, what is it? It is an analysis technique of the MSA used to assess the quality of the system by testing its ability to provide reliable, repeatable, and reproducible information. G stands for gauge, a measuring device or instrument. R&R stand for repeatability and reproducibility. Repeatability is an indicator on how similar the measurements are when the same part is measured several times with the same equipment. For example, if I measure the thickness of my cell phone with a caliper several times and the results are very similar, I can say that the system was able to repeat the results. Reproducibility is the ability of the system to provide similar results when several persons measure the parts. For example, if two other people would also measure the thickness of my cell phone with the same device and conditions, we can say that the system reproduces the results if all the results are similar. Before we can start a Gr&R study, we need to consider some important points. Our objective is to evaluate how good the measurement system is. For that, we need to challenge it. We are not performing a process capability analysis, but testing how measurements are obtained and how reliable they are. We want to know if the results are consistent when objects are measured several times, and whether other appraisers could obtain similar results when using the very same system. To challenge the system, I need to select parts which are good and bad. My system must help me identify the parts that are within a specification and those which are not. When the values measured are close to the upper or lower tolerance, the system must be able to tell me in a reliable way if the parts are still okay, or if they are perhaps out of a specification. The system must recognize those small variations of the parts. Therefore, please select wisely the pieces you will use for this study. Again, they don't need to be perfect and at nominal value. It is better if they are all different, because they need to show some variation. What do we need to perform a Gr&R? Of course, we need a measurement system, but additionally, what do we need? First of all, we need a coordinator. A coordinator will organize the study, select the parts, select the appraisers, and train them as well. He will make sure the study is well done and record all results. He should be an expert on MSA techniques. The coordinator will also gather the standards, specifications, and measuring procedures as needed. An important element is the place where the study will be done. It can be the production job floor, a laboratory, a special room, but it must have all the necessary equipment like the working area, chairs, tools and fixtures, and the right conditions like illumination, temperature, humidity, and of course, whatever I need to record the results. We need 10 parts to be measured. If possible, some of them should be slightly out of a specification, and all of them should show some variation and cover the complete tolerance range. The parts should be identified with a code that only the coordinator knows. We also need 3 people who know the products and the measuring device. They will measure the parts with the system. The appraisers do not know the sequence or number of the piece they are given. The parts must be given randomly to them to prevent memory effects of the appraisers. Of course, they should not witness other measurements nor see their previous results. We also need a measuring device. And once we have everything, we need to repeat the set of measurements 3 times. That means every appraiser will measure the parts 3 times. Once the measurements are made, the coordinator organizes the information in a matrix and makes the calculations. As you can see, he calculates the average value for every part, its range, and then the average value, standard deviation, and range of all the parts measured. With that done for every appraiser, we can calculate then the components' repeatability and reproducibility of the story. And later on, we will be able to make a judgment of the system. Please remember that we consider the parts as the references and estimate the bias, average of measurements, and standard deviation of the results. Then we can calculate the components of the R&R. For the calculations, we can use 2 different methods. We can use the average and range of the results or the variance to obtain the end results. In either case, the acceptance criteria are: if the result is lower than 10%, the system is good. If the result is between 10 and 30%, the result must be analyzed depending on the customer requirement and whether the equipment is new or not. If the result is greater than 30%, the system is not good. It must be improved before using it in the serial production. Now, what can I do with the results? The EV is the equipment variation, the component that tells me how the repeatability is. If its value is high, I need to see why. I need to verify the values of every part measured by every appraiser and in every trial, and try to find why they are different. The gauge might need calibration, it is damaged, or perhaps the measuring method needs to be improved. The AV is the indicator of reproducibility. If its value is high, I need to ask why and verify that all appraisers have been trained in the same way and they follow the same measuring method. Perhaps the alignment has a problem, or the fixtures are not okay, and so on. If the repeatability is good, I should train the appraisers and repeat the study. PV is the component that tells me how different the parts are. The variation must be detected by the system. This is related with the selection of the pieces. Take a look at the NDC, the number of different classes. If the parts are organized according to their values and shown in a bar graph, the NDC will be the amount of bars displayed. It must be at least 5. If not, the parts are too similar to each other and the system cannot detect any variation. TV is the total variation of all elements, parts, AV, EV, and the possible interaction among them. Gr&R is the end result of both components, EV and AV. Since we are testing how similar the results are for every appraiser and for the whole group, the deviations are not good. That means the smaller the value of the Gr&R, the better the result. And with this, we have reached the end of this video. If you are looking for some more information and similar videos, please visit our web pages, qualityautomotiveindustry.com or Quality Knowledge Online. Thank you for watching.